This video covers the overhaul of the ZF9HP48. This transmission is used on quite a few applications, including the Pilot, Honda Pilot, the Acura MDX, the Jeep Cherokee, the Jeep Renegade, some Land Rover vehicles. And it is a 9-speed front-wheel drive and all-wheel drive transmission. These video shots here are just basically kind of showing you what you see around this transmission when it's out. This, and for instance right here, this is the oil cooler, or you can call it the warmer too. Use those pipes that are sticking out there, receive the engine coolant, and they'll transfer the heat between the transmission fluid and the engine coolant with that. That plug on the top there is a dipstick plug that can be used from Chrysler, but they don't use that in the Honda applications. They have a different process. We see the TCM connector up top, and the TCM is mounted externally, as you can see. That orange plug is where the axle plugs in, and you can also see the fill level. That plug next to it is the fill level. So you pull that plug out, at a certain temperature, it should be level to the bottom of that plug. This is the pass-through connector and the pins that are related for the internals, the solenoids. This transmission has become quite infamous for its shift quality, its noise, and the weird, harsh shifts that occur now and again. There's that tag again, and if you also notice on the top, that lever that says up, that is a manual release for park because there's no cable that goes to this transmission. Park is controlled hydraulically. For one of the first things we want to do is just remove that oil cooler. We're going to remove some of the external things so they don't get damaged when we're flopping this transmission around on the bench. Remove the pan bolts. There's not too many of those. Now take a look at these valve body bolts. Some of them have thicker shoulders on them, and some of them have like tapered shoulders on them. The ones that have the thicker shoulders, you want to pull those out. The tapered ones hold the valve body halves together, so pull the thick shouldered bolts out first, and that'll allow you to remove the valve body from the transmission. If you notice, I'm sticking a nut in there. I use a pair of pliers. There's a very heavy spring tension holding that lever in the park position. So I shift that because it tries to bind the valve body when you take it apart. And you'll still have to pry on the valve body a little bit because there's feed tubes in this transmission, and you're going to fight the O-rings that are connecting between the valve body and the transmission case. So you can see some of those tubes stayed with the valve body, some of them stayed in the transmission case. Just use a pair of needle nose pliers and pull all those feed tubes out. They're pretty easy to figure out where they go. Now we also have to remove the Torx bolt that lives right there under the range sensor. Get that range sensor out of the way. It's a Hall effect type range sensor. And then we have this two-piece or two-part speed sensor that's held in by one bolt. That comes out pretty easily. We have to pull the clip off that holds the pass-through connector on. Just kind of yank that off of there with a pair of needle nose pliers. Now you should be able to push that pass-through connector through the case, and that would allow you to free the valve body from the rest of the transmission case. Just put the valve body off to the side for now, because we'll look at that later. We're going to go ahead and pull that transmission control module that's on top of the transmission off, so that way we don't damage it while we're rolling the transmission around. On the left side of the transmission, you want to put a little adapter. Actually, I use a lift adapter to prop the transmission up, so that way it kind of holds it level. And then you pull all the bell housing bolts out. I know it's the desire is there to use an electric impact or an air impact, but I don't want you to use an air impact or any impact. I want the threads on this case to live. There's some dowel pins that you have to fight, so use a pry bar or 2 pry bars and gingerly pry up around the case. It should break the case loose. And once you get it up far enough, you should be able to lift the case off the rest of the transmission. Right now is probably a good time to tell you that this transmission is extremely sharp. There's a lot of sharp edges on the machined aluminum. They don't pay any attention to deburring or rounding off the edges on anything. So you might consider wearing some nitrile gloves to protect your skin or some mechanics gloves. But if you don't, there's a good chance you're going to end up with cuts all over your hand. So there's the bell housing, and off of the bell housing came the filter and the pump assembly. We'll just put it off to the side to begin with. Remove the differential case. This is the E clutch. You can put it off to the side. This is a driving clutch. And I'll tell you, those little windows on the side, the speed sensor measures off those windows, and they are cut sharp. They will cut you up. This is the E clutch hub. This is an output gear assembly, and built into the output gear assembly is also the F dog clutch assembly. We'll see how that works later. Here's a transfer gear. We want to pull it off, and it's also got the transfer gear bearing on one side, the front planetary gear set, the front sun gear. Those teeth right there are what's going to engage into the dog clutch. You can see it spins easily right there, but there's a dog clutch that, when hydraulically applied, it locks that sun gear to the case. It's that front carrier. It's a middle carrier assembly, the front internal gear. Then you can pull this device out. This has a combination of gears in it. You're going to find there's 2 planetary gear sets, an inner and an outer planetary gear set. And then you'll see that the gear that I'm holding right now, it actually works as an internal gear and a sun gear. So there's gears meshed on both sides. So the internal gear will mesh with the small planetary, and the outside of that gear will be the sun gear for the larger planetary. They're pretty fancy with this gear set. They've managed to squeeze a lot of, but they say there's 4 planetary gear sets in this transmission, and they managed to package this in a pretty small unit. As I take these parts off, I pretty much stack them on the side. Now here I have to pull this D-clutch housing off, but you can see that bottom transfer bearing is in the way. So the first thing I have to do is pull this transfer bearing off. And there are reliefs cut, as you saw that note, there are reliefs cut in the transmission case to allow room for a 2-jaw puller. If you don't go into that reliefed area and you pull on the cage of that bearing, you'll ruin that bearing. So please place the puller in those reliefed areas. And make note of that shim. You don't want to lose the shim. Next we're going to remove the D-clutch housing, and we've got that bearing out of the way. This plate right here is a 1, 2, 3, 4 forward clutch pressure plate on a 6L80. A lot of shops would have that handy. There is a special tool that Chrysler sells for this transmission. I don't have it as of yet, but I really don't need it at this point, because using a broken reaction sun shell, which is like probably one of the most common failures on a 4L60E, and that forward clutch pressure plate, off a 6L80, I can get that spring compressed. So I put a crossbar on there, put a couple bell housing bolts in, and compress that housing. And what I'm compressing is the return spring. There's a piston return spring in there that I have to compress. Snap ring can sometimes be a bear. I've had luck on most of them just by using 2 picks and opening it up and getting a pick underneath it to pry it out, just like you see here. On some of the transmissions, I actually drilled a hole through the snap ring groove so you can get like a pick or a drill bit behind the snap ring to push it out of its groove. This one wasn't difficult. Then remove the special tools. Keep that bar handy because we could use it for this next step of pulling the housing out of the case. What you run into is the O-ring that seals off the outside of the housing. When it pops up, it actually falls in the snap ring groove. So if you put that bar back into its place, and we use a lady's foot, or they called it like a rounded head pry bar. I think that's the politically correct term, but the lady's foot is what a lot of people call it. Put a vice grip as a way to kind of pry up against that lady's hook. When you pry up on it, you'll see it'll pop that housing out of that snap ring groove. Then you can just grab it. But what ends up happening, like I said, is the O-ring falls in there. That's the spring that we had to compress to get that snap ring out. It's like a dish spring or a Belleville type spring. So this is the D-clutch piston. You can see here's a seal that lives on the outside. That's the one that fell in the snap ring groove, so we want to inspect that really well to make sure it's not cut up. And then these are the actual piston seals. They're lip seals. I like to leave the seals on them, and if I were to replace the seals, I would change them as I take them off, so that way I can line them up perfectly with whatever comes in the kit for an exact comparison, and also I'm making sure that the lips go the right direction. You can see the slots in that piston except the Belleville snap ring. Moving on, I'm going to take my tool off, and then I could pull the C-clutch hub and the D-clutch hub with the sun gear. I could pull that out of the transmission case. Now I can go ahead and pull my D-clutches out. If you reach in there, you can see that there are no wave plates. There's just flat steels and frictions on the D-clutch. That's going to be important to note, because when we do clearance checks, we have to apply force on it, and you'll see the force doesn't change much. Now on the case for the C-clutch, there is a little tab that sticks up on the pressure plate. Just kind of take note of that and where it's located, because when we take this transmission apart, we have to split the snap ring across that tab. You can see this C-clutch, it also has just steels and frictions, pretty thick steels and double-sided frictions. Here I'm showing you how that snap ring has to be separated around that tab that's on the top plate for the C-clutch. This is the B-clutch. B-clutch is a driving clutch, and it allows my input shaft to drive a sun gear, the rear sun gear. Pay attention to that Torrington bearing at the end of this assembly. It's easy to install that upside down and it won't fit right. It also likes to pop out all the time. Remove the C-clutch piston is our next step. And here we'll use another homemade tool. That's a 3.5R steel plate out of a 6L80. And for every 3 teeth I ground 2 of them out. And also welded a backing plate to it to stiffen it up. So the trick here is that those little fingers are going to push down on the C-piston return spring. That's why it requires a special tool, because there's really nothing else I can get in there. put something across that to take up space. I'm using a 4L60 low support assembly and a clutch spring compressor, just a universal one. And using that bar with a threaded rod going through the middle, I just thread that down to compress that spring. It's going to go down far enough to the point where I'll be able to get the snap ring out fairly easy. The snap ring is kind of unique. It's got a little step on it that helps center that spring in there, and it also has these raised ears at the ends of the snap rings, so it'll only fit in one position in the case. So I'll take the special tool assembly out. Take your spring out. To get the piston out, we'll blow air into the case. It'll probably pop the piston out sideways. So a lot of times I'll take a screwdriver or one of the J28 585s, and I'll kind of push down on the part that popped out and blast it with some air again, and that'll cause it to pop out in different spots. Otherwise, it can be a little difficult to just pull that out. Here we can see we got an inner seal and an outer seal on this piston assembly. If we were rebuilding this transmission, we'd want to replace those seals. Now we're going to go through and we're going to pull the stator support and oil pump out. So we're back over on the bell housing half of the transmission. This is the stator support assembly. It's actually a thrust washer that's located there on top of the oil pump sprocket. Now I'm taking the filter bolts out. This filter is not replaceable unless you're rebuilding the transmission. That's an extra feed tube that is for feeding the two-stage pump, and those are the magnets that are there to kind of catch metal in the transmission. That crossover pipe right there feeds oil to the oil cooler. Now we remove the bolts for the oil pump housing. There's some dowel pins in the oil pump housing, so it can be a little difficult to get that to free up, but if you gingerly use a pry bar, you can get that housing up. Just be careful not to put too much force on anything. And that's your oil pump up there. It's a chain-driven oil pump, an off-axis oil pump. And there's that thrust washer I was talking about, and the drive sprocket. Now to get the pump out, we actually have to compress it because there's a dished plate on the back of the oil pump. So I use these welding clamps, and you gotta make them pretty tight. Doesn't look like it moved in much, but it moved in enough to the point where you can get a pair of needle nose pliers, squeeze that snap ring together, and that'll allow it to pop out of the bore. You can see the snap ring pliers are loose and they're in. And use a screwdriver and very carefully kind of wiggle that pump up out of there. There's an O-ring that's going to provide a little bit of resistance. And now that you have it out, you're going to notice that the pump's actually hard to spin, because that dished plate that's on the back is going to pull that pump assembly tight. Kind of works like a spring. It also makes it a little difficult when you disassemble it, because when you pop that E-clip off, there's tension on it because that dished plate is pushing on it. When you disassemble this oil pump, study its operation. You can see it's got vanes and a rotor, but when you look at this, you're going to see that there's multiple inlets and multiple outlets. So it's like a dual stage pump. And when you put it back together, also notice that you can assemble it wrong. The outer section of the pump is kind of a raised lip that goes around it, and the center section of the pump will follow that raised lip almost perfectly. If you have something offset like 180 degrees, it's pretty easy to tell, as long as you can see that lip, that it's not following that same contour and you've got it assembled wrong. When we go back in, kind of like when we took it out, we're going to have to go in and compress the pump using those welding clamps or something similar. That dished plate that's on the back of the oil pump is going to need to compress a little bit to provide enough room for us to get that snap ring installed in that oil pump housing. So you have to squeeze that fairly tight, and then once that snap ring's in there, you can kind of tap it in to make sure it's seated. Next, we're going to disassemble the output gear and the F-dog clutch assembly. One of the first things we need to do is take a pin punch and uncrimp the little safety mechanism that goes around the nut that keeps it from loosening up. There is a special tool, a special spanner wrench or socket to remove this nut. We don't have it. It actually doesn't take that much torque to loosen it. I think the tightening spec is only 44 foot-pounds. Then when you take the nut off and you take the little retaining ring off, put it to the side, you find a socket that will just kind of hit the center section, and you can kind of slam. It's not a very tight fit, so you can slam that output gear assembly up against the socket, and you can see the bearing and the gear comes off. And now I have access to my housing with the F clutch assembly in it. The F clutch assembly is a holding dog clutch. So you can see when I put air pressure into it, the clutch goes up, but the dogs go up, and then blowing air in the other direction, it'll force it down. With it forced down, I have room where I can get a screwdriver or a pick and kind of pop that little thrust washer off on the top. Then I try to fight and get the snap ring out, but you can see it's kind of a bear. It's a tight snap ring, and the pick doesn't want to seem to pull it out. So I did this for a little while and I gave up. And what I ended up doing is I drilled a hole through the snap ring groove. And then with the a hole drilled in that place, you can move the snap ring around and kind of cover the hole up. Then you can use the drill bit, the end of the drill bit, to push the snap ring out of its groove. Now if you flip it upside down and you apply air pressure in the direction, in the correct direction, it will pop that piston out for you, which is nice. So there's my dog clutch assembly, and you can see I've got some seals that are located on it. Kind of using the pick to show that, where I've got an inner seal. That's something you want to replace. I've got an outer seal right here. These are just O-rings. There's a seal in the housing assembly itself. And then I have a seal on that little ring that I had to use air pressure to pop out. So if you're rebuilding this assembly, you're going to want to make sure you replace all those seals. I would change them one at a time so I could size them up accurately. Then once everything's clean and new seals, everything's lubricated, you can push it all back together. This top shim assembly or piston assembly is going to need to be tapped down a little bit, because you're going to fight the O-ring that's on there. Then you're going to have enough room for your snap ring. Pop your snap ring back in. And then place your thrust washer back in there. It kind of clicks into place, which is nice. That's actually a bearing surface for that goes between the sun gear and that housing. Probably best would be to find something that would contact the inner race, but I just used a hammer. It's not a very tight fit, so I just used a hammer and just went back and forth. A soft face hammer, and that kind of walked it down there until you hear the sound change and you know you're pretty much all the way down. And you can go ahead and put your locking ring back in. I'm sure with the kit you'd probably get new, I don't know if you get a new nut there, but you'd likely get a new locking ring. The good thing about using the old locking ring is the spanner, especially if you marked the little spanner openings before you took it apart, that you should end up in the exact same spot when you go together with it if you're using all the same parts. Now it's time to start reassembling the ZF9 HP48. After inspecting everything and everything looks good, we're going to start with the C-clutch piston. Install the piston in the housing. You're going to fight the seals a little bit there, but it should slide in okay. Put the dished return spring, piston return spring, in place. Then use our special tool to go through and compress the spring, put the snap ring in there. Here you can see I'm assembling the special tool with something to kind of build up the center of it so I could push down on it. And there's that crossbar. Tighten that up to the transmission case using bell housing bolts. And use a wrench to push down on that clutch compressor. The ends of the snap ring kind of curl up, and you want to make sure those curl up. And then there's a step on the snap ring that's going to be facing down. That helps center the piston return spring. And you can see the opening of the snap ring is going to be like in the 6 o'clock position as shown in the video there. Just kind of work that snap ring into its groove and make sure it's in there completely. Then we can take the tools off. With the tools out of the way, we can go ahead and install our C-clutch. We'll start with the steel and alternate steel friction, steel friction. Remember that top plate has a nub that sticks up, and you'll have to split the snap ring across that nub like it's shown here in the video. Now we want to check our C-clutch clearance. We're using that same piston spring compressor, and what we're going to do is apply force to that pressure plate. The service manual has us apply 45 pounds of force. So this is a little homemade force gauge. When we push down on that center piston, the pressure gauge is going to read up. That piston in there is a 1 square inch piston. So when it shows 45 pounds on the gauge, we know that we pressed down on that clutch pack with 45 pounds of force. And there's an opening on the valve body side where you can get access to the clutches, and you can actually measure between the snap ring and that top pressure plate. You want to compare that to specs. You'll probably have to stack your feeler gauges like right here, and that's with 45 pounds of force on it. In the worksheet, you're going to have to do that same measurement with force and without force to get an idea of how much it changes. Now we're going to check the D-clutch clearance. With this step, since that snap ring is a bear to remove, when you slide the snap ring in, only put it in like 2/3 of the way around. So I left one end of the snap ring sticking out of the snap ring groove. And then where I'm in the snap ring groove, go ahead and do a measurement between the case lug and the snap ring. That's going to give us our total dimension there, our total distance between the snap ring and that case lug. Then we're going to go over to the arbor press and build our piston and our clutches with the steels. We're going to build that up on a plate. and put something across it because we have to use our force gauge again. Once again, we're going to apply 45 pounds of force. I don't know if a wrench is the best thing. The wrench does flex a little bit, but it's still going to exert that force through it. And with 45 pounds of force on that clutch pack, we're going to measure between the housing step and the clutch pack assembly. So now with these two measurements, I can compare the total distance that I have between the snap ring and the lug in the case, which is my total clearance, and I compare it to the housing to the clutch pack, and I could subtract these two to find out what the difference is, and that would actually be my clutch pack clearance. I have you do that measurement using 0 pounds of force, 45 pounds, and then 100 pounds of force to see the differences. Once we finish our clutch pack measurement, we can go ahead and install the D-clutch. We alternate steel friction, all the way up to the point where we get to the housing. Now before I put the housing on, I have to go through and install my input shaft with the B-clutch. So this is going to be the B-clutch measurement. I take the B-clutch, I take the snap ring off the input shaft so I can get the B-clutch in the arbor press by itself. That adapter right there is a 3/4 apply fingers that are found on the 4L60E. Many shops would have that laying around. It will reach in there and grab onto that clutch pack, as you can see. And with 45 pounds of force, you can see the clutch pack, and on this clutch pack it actually does compress. So you want to measure that gap between the clutch housing and the clutch pack. Then reassemble it and put it all in the case. Now I can put my rear sun gear with the C and B clutch hub on there, and the D clutch hub goes in as an assembly. We have 3 sets of clutches that we have to line up. We have to line up the B clutch assembly into the hub. We have to line up our C clutch assembly and the D clutch. So there's quite a bit dropping in. You're going to have to twist the input shaft, twist the sun gear, twist the internal gear, and hopefully all those will eventually drop in and get you to the bottom of the case. You want to make sure these are all dropped in, because if you're stacking this gear setup and any of these are sitting up off of a clutch disc because it wasn't fully engaged, when you start assembling the transmission and you start tightening things down, you might accidentally crush those clutch discs. So now we're at that point where we're going to install the piston return spring and the housing. When you put the housing in, it's going to slide down and that outer seal might fall into that snap ring groove. And we're going to have to use our special tools again to compress that spring to provide access to that snap ring groove. So we've got our little 1, 2, 3, 4 apply plate from our 6L80 and that broken reaction sun shell, and we're going to tighten down that crossbar. Tighten it down evenly from side to side. I'm using a little soft face hammer to kind of tap it down to kind of keep that housing square when dropping it down in there. And then all we have to do is kind of spiral our snap ring into the snap ring groove. Might have to give it a couple taps there to make sure it's seated. Try not to gouge the aluminum housing. And then we remove our special tools, and that D-clutch housing with all those clutches should be in place. At this point, I can start assembling some of the gear set. I've got my internal / sun gear assembly with the Torrington bearing. I'm going to slide that into the carrier. Make sure everything spins smoothly. Put my Torrington bearing there on the top. I got a little trans jaw on that, but I really don't need it because it's not going to go anywhere. Then I spin that whole assembly in. That internal gear / sun gear assembly also has the dog teeth that receives the dog clutch there in the middle. Then I install my internal gear / carrier. I'm checking the pinion gears here for side-to-side movement. You can see they actually have quite a bit of clearance on these, and this is a brand new gear set, so that's just the way they are. Spin that assembly in until everything drops down. This is my front sun gear that also accepts the F-dog clutch. Slide the carrier in around it. Before I put the output gear on, I'm going to have to pound in that transfer bearing. I use a socket or a pipe that contacts the inner race and tap that down using a soft face hammer. It doesn't give us too much trouble going on. Now we're going to check this E-clutch clearance. This is the disassembled view of the E-clutch, the very top clutch in the transmission. We're going to take these parts over to the arbor press. We're going to use that 3/4 apply finger from the 4L60E. And I've got the dial indicator mounted to the top of that. And I'm measuring the total amount of movement of that clutch pack just with some picks. I use that apply finger assembly because I really can't get onto that clutch assembly very well. Now I got to put 45 pounds of force. The previous measurement that I had there was about 33 thousandths of an inch of clutch clearance. And using my force gauge, I'm going to have to put 45 pounds of force. And I'm going to watch how far negative from zero the dial indicator traveled. And you could see here that we traveled about 17 thousandths of an inch negative from the 0 point. So without any force on it, it was close to zero. And then with the 45 pounds of force, I got negative 17. So you would add your 33 thousandths that you received with no weight on it to the 17 thousandths that you had with 45 pounds of force, and your total clearance then would be about 50 thousandths. At this point I could start assembling the rest of the transmission. I had to put the parking pawl assembly in there. The transfer gear assembly. And now I could slide the output gear and the F-dog clutch assembly in there. Make sure you line up the teeth that are on the output gear with the slots or the openings that are in that front carrier assembly. Then I can go ahead and slide the E-clutch hub down. And I could slide my E-clutch assembly on over the hub. I have to line up those clutch discs by rotating that E-clutch assembly. You might want to do this with gloves on it because those slots, those openings on the side of the E-clutch drum are extremely sharp. I cut my fingers up pretty bad just doing that. They're like razor blades, so you really don't feel it cutting you until later. Here I'm shining a light in there just to show you the splines and the E-clutch assembly and how they are pretty close to flush. They're not exact, but they're pretty close to flush. You put your case gasket on there, and I'm just showing you the measurement here. It's about 17 thousandths of an inch thick. So you don't want to forget that because that does actually provide clearance between the bell housing and the case. This is an extra measurement that I decided to do because you don't want to put the case on or the bell housing on and crush anything. So I'm laying this across the case and I'm measuring from the straight edge down to the surface where that'll be contacting on the bell housing. And I'll use that measurement as kind of a reference. Now that I'm on the bell housing side of the transmission, I'm going to go ahead and put the oil pump housing with the sprockets and the chain on there. There are some dowel pins that help align the oil pump to the bell housing. So So it's gonna, once you get that on there, you're probably gonna have to take a soft-faced hammer and tap it side to side to let it wiggle in position. Just be gentle with all these taps and impacts. That little shim goes between the stator support and the drive sprocket for the oil pump. Install our stator support and also install the oil pump housing bolts. Snug all those down. Obviously we would torque everything on a live job, but with these lab units I like to just give it a little snug because I want these threads to last. This is the oil filter assembly. Wiggle that in place and put your oil filter bolts in. Snug those down. This is not a replaceable oil filter unless you're overhauling the transmission. Place this feed tube in position. This is for your cooler oil. And now I can take my bell housing and place it on top of the transmission. There are some dowel pins that you have to line up between the two case halves. You can rotate that output gear for the transfer case. You don't want to draw these parts together with bolts. If there's something holding it apart, you need to figure out what it is. Between the output gear housing and the oil pump housing, there's a dowel pin. And you might have to stick your finger from the valve body side, stick your finger in there to get them to line up. You still see there's a gap there. Right about now it seats. There is a rubber gasket that lives between the case and the bell housing that might spring the case up a little bit. If you push down on the case, it should sit flush. Also, between the oil pump housing and the output gear housing, there should be a slight gap before you put the bolts in, so you could actually stick a feeler gauge in there to make sure there's a bit of clearance. Before putting on the valve body, we're going to go ahead and do some air checks through the transmission case. On this slide you can see we have a variety of different spots. Matter of fact, we could check every clutch in this transmission through the case fairly easy. And the first thing we'll check is the dog A clutch. I use this little plate right here. It's a Sonic's wet air test plate with a little rubber gasket underneath it. I do it this way because it's kind of hard to test it without that plate. The opening is so large that when pressure builds up in there, it pushes the plate back and you end up hearing it squeaking out of there more than applying the clutch. So I drilled a hole in that plate so that way I can get a better seal, and it allows us to air check those clutches. You might notice that there's quite a bit of air leakage, and I'm using about 60 psi of air pressure. We'll check the F-dog next, and if you haven't already put these aluminum feed tubes in, you should put those in. The F-dog also has a bit of air leakage, especially when you're checking the F-dog on circuit. Next we'll check the E-clutch circuit. This clutch applies through some sealing rings, so you might hear a little bit of leakage, and if you rotate the input shaft it might actually seal up a little better. Next we'll check the C-clutch and see how well it seals. It actually has a decent seal, although you do hear a little air leakage. Next we're going to check the D-clutch, and we're going to use that Sonex plate and bolt it to the case again. That plate is necessary because with all that air pressure behind the plate, just with hand force, it will lift the plate off of the case and make too much noise. We won't really be able to hear the piston apply. With the B clutch, we get the worst air test out of them all, and even with the plate in place and 60 psi, we can hear the piston apply. You can't see the piston apply because it's a driving clutch and it's located at the bottom of the gear set, but it does not air test very well at all. This section covers the ZF9HP48 valve body overhaul. The valve body has 10 solenoids, 2 speed sensors, a range sensor, a pressure switch, and a thermistor. Built into the connector, we can see the thermistor assembly. And at the end of the valve body, we have a pressure sensor that's going to measure line pressure in the transmission. We have a range sensor hooked up to the manual valve linkage. And we also have some speed sensors measuring input speed. This image here shows the layout of the solenoids. On the top, that brown solenoid is going to hold the manual valve when we're out of park. And all the black and gray headed solenoids are going to be inversely proportional, which means when they're electrically on, they're hydraulically off, and when they're electrically off, they're hydraulically on. And all the orange headed solenoids are proportional, which means they're electrically off, they're hydraulically off, and when they're electrically on, they're hydraulically on. This video sequence will show the inversely proportional solenoid, and it will basically show with the air pressure applied that when the solenoid is on, it's hydraulically off, and when the solenoid is off, it's hydraulically on. So when you energize the solenoid, it actually prevents fluid flow from passing. And the resistance, since it's a PWM solenoid, it's a low resistance solenoid. With these proportional solenoids, it's the opposite, which means when we're electrically off, we're hydraulically off. And when we're electrically on, we're hydraulically on. You can see in this example, when the solenoid turns on, we hear air passing through it. And when the solenoid's not energized, it's trapping. It's not allowing air to flow through. We also see this as a low resistance solenoid at 5 ohms. It's also pulse width modulated. The dog solenoids A and F are also proportional, meaning when they're electrically off, they're hydraulically off, and when they're electrically on, they're hydraulically on. As you can see as I'm pulsing the solenoid on and off. These solenoids have a little higher resistance. They are reading about 11 ohms. A little smaller solenoids too. Lastly, we have the park valve holding magnet. So when we take the transmission out of park, this will actually hold the manual valve in its position. You can see I'm pumping this thing back and forth, and when I energize it, those little fingers hold on to that pintle there, and that will lock the manual valve, kind of grab onto the manual valve, and you can see I just released power and it extended. It's a much higher resistance, it's only 24 ohms, so this is likely just an on-off type solenoid. When we take the valve body apart, pay attention to that little clip so that way you don't lose it or forget where it goes. And when we split the valve body halves, you can see that our spacer plate has kind of a gasket material built into it. We can also see we have quite a few check valves in this valve body. The red, black, blue. There's a variety of different check valves. We also have this like dumbbell looking check ball assembly. So we want to keep all those things intact. There are also two of these dowel pins that keep the two valve body halves lined up. When we strip the valves out of the valve body, pay close attention to the direction of the springs and any kind of plugs and little plungers that you might have in some of the valves. On this first valve body here that we're looking at, from left to right, we have a boost valve, a solenoid limit valve, and then the B, D, and C pressure regulator valve. Note the location of these little clips in this valve body half here. You have to take these clips out so the valves can come out. This half of the valve body is where the solenoids live. And going from left to right again, we have the park lock, the park cylinder valve, clutch C pressure regulator valve, clutch D pressure regulator valve, dog F pressure regulator, and then dog A pressure regulator. Flip the valve body around, and from left to right we have the pressure regulator, a lubrication valve, and a torque converter clutch valve. The purpose of disassembling the valve body like that is to obviously do a good job of thoroughly cleaning it, but also to inspect any of the bores for gouges, check for any valves that are sticking or hanging up, check for any broken springs, and if you have the ability to do vacuum testing to see if any valve bores are worn out, you have to take it apart to clean it to get the oil out, and then you can go through and do some vacuum testing. Now we're going to go through and assemble the valve body onto this CF9HP48. First we're going to go through and stick those feed tubes in there. They're fairly obvious. Of the smaller tubes, there's one of them that's a little longer than the others, but you can see there's a deeper recess for it. Then we'll install our speed sensor, our combination speed sensor assembly, tighten the bolt up to that. Next we have our pass-through connector, and you can see there's a flat edge on there. That flat edge faces towards the rear of the transmission. You got to wiggle that thing through, get those O-rings to fit. They fit pretty tight in there. And there's a clip that holds it all in place. So you want to slide that clip up. It has a little tang that'll snap in place. Make sure the range sensor is over the linkage. And the wiring there, you can see we have to push that wiring up around those passages. If we don't do that, it's likely going to get pinched between the valve body and the case. Now I can go ahead and slide my valve body into place. I'm lining up those feed tubes to the valve body. The O-rings are going to provide a little bit of resistance, so I'm going to wiggle it back and forth and push it in. That thing should snap flush. If it doesn't sit flush, there's something that's holding us away from the case, and we definitely don't want to put the bolts in and tighten them up at that point. Go ahead and put the valve body bolts in and torque those down, and then we're done with the transmission's valve body. Go ahead and put the oil pan on and tighten those bolts up. And on the top, don't forget, we've got the transmission control module. It's a good idea to put that on last so that way we don't accidentally damage it. And lastly, we have the oil cooler. It's got 3 Torx bolts that hold the oil cooler to the side. So that about sums it up for this ZF9HP48. I hope you gained a little understanding of how this transmission is put together. I think it's a well-built transmission, even though I know they have plenty of issues and troubles with the shift qualities in this transmission. I'm pretty confident that they will have this figured out through software, and this will be a fairly durable transmission.